Hello, Year 7 mathematicians. We've been looking at Pythagoras, and you all should now know this lovely formula that a squared equals b squared plus c squared, provided we have a triangle where a is the hypotenuse, the long side of the triangle is the hypotenuse. Try and remember, hypotenuse is a long word. Hypotenuse. And the hypotenuse is a long word which applies to the long side of the triangle. So there's A, and there's B, and there's C. Now, you sometimes see it the other way round. You can see sometimes the formula written like this, that A squared plus B squared equals C squared. But that applies to a different triangle. Excuse me, that applies to a different triangle where it's just been labelled in a different way. Here, the a squared, the a is the hypotenuse, the long side of the triangle. But if the formula is written in this way, it means that c is the long side of the triangle. So the letter which is on its own on one side of the equal sign is always the hypotenuse. I suppose you could always write it something like a squared plus c squared equals b squared. Is that visible in the viewfinder? Yes, it is. But that would be a bit silly, a bit obtuse, a bit difficult on purpose. So you never see that. But sometimes you see Pythagoras written this way, and sometimes you see it written this way, and the letter which is on its own is always the hypotenuse. See? And there's the A, and there's the B. So there are different ways of labelling the triangle, let's put the right angle in. Let's put the right angle in there as well. There are different ways of labelling the triangle, so there are different ways of stating the formula. And if somebody gave you a triangle like this and said, well, I've got a triangle with a height of h and a width of w, what's the size of this diagonal? Well, it's now labelled in a completely different way, but the diagonal part here is the long side of the triangle. Notice that the hypotenuse doesn't touch the right angle. It's the two short sides that touch the right angle. The longest side is away off over here. Look, there it is. There's the right angle, there's the hypotenuse over there, there's the right angle, there's the hypotenuse over there. And what that means is that in this case you would write the formula, well, the hypotenuse is the one that's on its own on one side of the equal sign, d squared equals, and then you've got to take the other two, h squared plus w squared. It would be just as correct, of course, to write that d squared equaled w squared plus h squared. If we add w squared and h squared, it doesn't matter whether we put the h squared first or the w squared first. So that sorts that out, and that means that you can expect to see the Pythagoras formula written in a lot of different ways, and you can apply it in multiple different ways. One of the things that can sometimes happen is that you're given a problem like this. Let's suppose we have an isosceles triangle, like that. There's an isosceles triangle. Not a very good one, I tell you what. We'll try and draw a better isosceles triangle. Here is an isosceles triangle. There we are, that's better, I think. I ought to be using a ruler for this, but we haven't got time on a video like this. So let's say that that's an isosceles triangle. You can always cut an isosceles. These are the equals. These are the two sides that are equal. We can label them like that to show that they're equal. These two angles are equal. And you can always take an isosceles triangle and cut it into two equal sized parts by dividing it along its middle like this. And that bit is a right angle. And that means we've now got two right angle triangles here, one on the top and one on the bottom. Now, if somebody told us that this distance from here to here was d, and that this distance from there to there, d for a depth or a distance, whatever it is, and that this length from there to there, let's label this triangle. There's A, B, C, and this is the point D. So the distance D is equal to AC. If we go from D to B, Donald Duck to Bertie Bonkers, D to B, we could say that that was a length L. And if we want to know the size of this hypotenuse, let's call it H, we would need to apply Pythagoras' theorem. But now we're applying Pythagoras' theorem to a triangle. If I take one of these triangles out and have a look at it, our triangle is now, well, there's H and there's L, but this whole thing here is D, so this is only D over 2. And now we have to apply Pythagoras' theorem to that triangle with an H, an L, and a D over 2 in it. And that means that we've got to write that H squared, the hypotenuse, is always on its own on one side of the equation. H squared equals the square of this thing and the square of that thing. And that means we need to be a little bit careful. We need to say that it's D over 2 squared plus L squared. Now D over 2 squared is not the same. Let's make sure that this is visible in the viewfinder. D over 2 squared is not equal to D squared over 2. Because if we take D over 2 squared, we have to square the D on the top, and we have to square the 2 on the bottom. So that means this is equal to D squared plus L squared, but the D squared is over 2 squared, which is 4. So that would be our formula. And now if we knew the numbers, if somebody told us that D was a certain number and that L was a certain number, we could put them in and do the calculation and find out what H squared is, and then find out what H is. So that's something that, to tell you how you can apply Pythagoras' theorem to triangles which are labelled in different ways and where you get different numbers turning up. So I'm going to stop that video now, and I've got another one that I'll send you in a minute.